screen. Okay, so before we start our meeting for today, let me just ask you guys if you have a question so far. Questions or clarification regarding with the laboratory, with our lectures, with our quizzes, anything.
Wala naman po, sir.
Okay, so what about the others? Anyone? Wala? Alright, so mahilig kayo sa wala. Alright, so if you guys don't really have a question, so I'm thankful. So hopefully, having or that doesn't having question, meaning you were able to understand everything clearly. Okay, so I hope that's the meaning of not having a question at all. Okay. All right, so let us start now with the module 4. So I hope you guys already started writing this one, these Maxwell loops, or sometimes we call this one mesh current method. Okay, but mostly 70%, okay, we use this one, the mesh current method, instead of the Maxwell loop method. Okay. All right, so to start with, who is the founder of this one? So the founder of this one is Mr. James Clark Maxwell. So again, as usual, whoever is the inventor or the one who was able to develop or found out this theorem, so his last name will be the one to use to name that specific theorem. So generally, we call Maxwell loops current method as mesh analysis. So we actually have a lot of names when it comes to Maxwell loop. So it could be Maxwell loop current method, mesh analysis, okay, or mesh current method. Okay, so we very widely use this circuit analysis technique. So in Maxwell loops current method, first we identify all the meshes of the circuit. Okay, so in here, yes, we have the name loop, but the one that we're only considering is the meshes. Okay, so last meeting we have discussed the difference between meshes and then loops. Okay, so contains only one loop, okay, or one loop inside of it only, but a loop it can contain one or more. Okay, so that's their major difference when it comes to mesh and then a loops. So we imagine one loop current for every mesh. So the direction of the loop currents may be arbitrary. So we could use conventional or the current flow method. So, but generally, we consider co-directional loop currents for the sake of our calculations only. Okay. So, without a further delay, let me tell you guys the difference. Okay. So, I would say that again, 80% okay of computation is super similar with the Kirchhoff's law. Okay. It's just that this one doesn't use KCL. Okay. This one is only using KVL, but with additional things in it. Okay. So later on, you will see the difference between Kirchhoff's and then Maxwell. So this current method or mesh analysis method is quite similar to the branch current method in that it uses simultaneous equations. Okay, it also uses Kirchhoff's voltage law, like what I mentioned a while ago. It also uses Ohm's law, of course. So without Ohm's law, you won't be able to verify if your answer is correct or no. Okay, everything, even in voltage, Kirchhoff's voltage law, it's still using Ohm's law. Okay, to determine unknown currents in a network. So it differs from the branch current method in that it does not use Kirchhoff's current law. Okay, so this is the only difference that uh, we could think about when it comes to Kirchhoff's and then Maxwell. So when we see Maxwell current method, it doesn't use Kirchhoff's current law, the KCL. And it is usually able to solve a circuit with less unknown variables and less simultaneous equations. So as you guys can see right here, you already know that this is much more better. It's a lot easier, okay, a lot faster than using the Kirchhoff's law, okay. So like for example, instead of having a five equation in Kirchhoff's law, but in Maxwell law, you will only have three equation. Okay, so of course, solving three unknowns is better than solving five unknowns. Okay, which is especially nice if you're forced to solve without a calculator. Okay, so this is also advantageous if you're not going to use your calculator, because if you have five unknowns, you cannot solve that one right away using your calculator. But having three unknowns, it's super possible, okay, to solve that one also without a calculator. Okay, but of course, it's a lot faster if you're going to use your calculator. Okay. All right, so for you to be able to see the difference, so let's have this example. Okay, so let's see how this method works on this example problem. So I believe that this is the same example that we have used in the Kirchhoff's law. So we have here the 28 volts, 4 ohms, 2 ohms, 7 volts, and then 1 ohm. Okay, which is the same with this one. Still 2 ohms under intersection. All right, so the first thing that you guys need to do is, of course, identify the loops. So as usual, the same process, just like what we have in Kirchhoff's law. So when we say loop, okay, so all in all, you could have three loops in here, okay? One, two, and then the outer loop, which is three. But then again, since we are in meshes only, so we're only going to count the mesh, okay, not the loop itself. So if we're going to have a mesh, okay, not a loop, so we're only going to have two meshes. So this is the first mesh, and then this is the second mesh. So how do we identify again the flow of that mesh or of that loop? Okay, so in my case, I always base it on the outer part, okay, of the voltage source. Okay, so in here, I always go with the positive leaving, okay, polarity of the voltage source. So wherever is a positive, that is the flow of the current. So that is why we have here clockwise. Okay, but in here we have here the positive. So as you guys can see, we have here a counterclockwise flow of current. Okay, so from here going to here. Okay, and then they will intersect right here at this node, and then they'll combine at this R2 right here. Okay, so that's how we assume the polarity of your loops or meshes. So if the assume again, if the assumed direction of a mesh current is wrong, then the answer for that current will have a negative value. Okay, so even though that's a negative value, that is still the correct value that we are looking for. Okay, so just let's say if it's clockwise, then just make it counterclockwise and then remove the negative sign. Okay, and then you already have the correct assumption and then the correct value, okay, or the symbol of your value, okay, or of your output. So it's not negative anymore, it's now positive. Okay, so after identifying the loop, we can now label the voltage drop polarities. So of course we have here the negative, positive, and then in here, since it's a voltage drop, so we have here the positive and negative. Okay, so it is not negative and positive. Okay, since we are considering the outer or the leaving symbol of the voltage source. So positive is a sign of this one, and then upon crossing this resistor right here, it will give you a voltage drop. So it will become negative. So the same with this one right here will give you a negative sign. So that's why we have positive and negative. Okay, so the same concept on the right side. So we have a positive right here and then negative below. Okay, and then positive, negative, and then positive, negative. Okay. So are we clear so far regarding with the labelings of voltage drops, okay, with the polarities? Can you guys follow so far up to this point?
Yes, sir.
Okay. What about the others? Only two?
Yes, sir.
Okay, very good. So again, this is super similar. Whatever you guys are doing in Kirchhoff's is still the same with the Maxwell, okay, Maxwell loop method. So later on you will see the difference. But for now, everything is super the same. Okay, whatever we are doing in the first and second steps, it's still the same right here. Okay, so that is why I am not reading most of the definitions since they are just the same. Okay, and then after that, so using Kirchhoff's voltage law, we can now step around each of these loops, generating equations representative of the component voltage drops and polarities. Okay, so in here you can identify the KVL. So you don't, again, we don't use KCL, okay, in Maxwell. So we go straight or we go directly to Kirchhoff's voltage law. Okay, so let's start with the first loop, first or the first mesh, the I1. So considering this one first, the voltage source, so will give you 28 volts, and then minus I1 times R1. So I1 and then R1, the value of R1 is 4, so it's already right here. And then going right here, so we have minus I1 times R2. So I1 times R2. Okay, so it's already 2 ohms. But as you guys can see right here, we have an additional one, which is the positive I2. Okay, so this is now where the difference will be coming from. So if it's Kirchhoff's law only, so we only have this one, 28 minus 4I1 minus 2 times I1. Okay, but since we are talking about mesh, okay, so we now have to consider the loops or the flow of current that is going on the other side, on the I2 loop. Okay, so if you guys are going to take a look on this one, so let me just copy this one and paste it on the paint. And let me also get this one. There's the equation right here. Okay, so as you guys can see, we have already the 28 minus 4I1 minus 2 times I1 only, supposedly, if it's the method of Kirchhoff's. But if we're going to consider the flow of current on this one, so if you're going to analyze this one, so we have this flow of current, and then we have this flow of current on the I1. Okay, so we have that kind of setup. So as you guys can see, we have the same flow of current, so that is why they will be added with each other. So negative I1, okay, so it will be added with this I2 also. So it will become negative I2 once you have already distributed this negative sign right here. Or let's just simply say that I1 plus I2, okay? So again, the one that we are considering here is the if they are the same flow of current or if they are not the same flow of current. So what if we have a flow of current that is, let me just remove this one for now. What if we have a flow of current? Let's say we assume that we have this kind of current in here. So basically this one is still positive negative, okay, but this one now will become positive negative positive. This one is still correct. Okay, so negative and then positive. Wait a second. Positive, negative. So it will give you a voltage drop. Positive, negative. Hmm. Bakit parang... Okay, let me just remove this one to avoid confusion. So if I will put all of the polarities right here, we have positive, negative. Yes. And then we are now dealing with the negative sign. So it's now negative and then positive. Yeah, that's correct. And then negative and then positive. So if you guys are going to take a look at this one, since in my case, I always go with the outer sign. So of course, it will give you negative 7. And then in here, it will give you a positive value. Okay, since we're talking about voltage drop. So uh, it could never be a negative R2 times I2. Okay, that's because they will be added with each other already. So if you wanted to make this one as a voltage drop, so this one should have a different symbol or polarity, which will make this one positive. So again, outer, outer, and then outer. So negative I2 and then I3. Okay, so that's how it will go if we have this kind of flow of current. Okay, so oops, why are they still the same? Ah, okay, so yes, we they have the same symbol. They still have the same symbols or polarities. However, the flow of current now is going right here. Okay, and then as you guys can see, we have the current that is flowing right here going down and then right here going up. So if we have this kind of scenario, then this one now will become negative since it's now negating, okay, the value of your I1. Okay, so they will not be added with each other anymore. So to avoid confusion, you have to disregard this one. Okay, so this is only the indicator at this point only. Okay, negative 2 times I sub 1, and then check if they have the same flow of current. And if they are the same, then it's positive. But if they are contradicting like this one, so going down and then going up, then this one will become negative I2. Okay, So that's basically what will happen if they have different flow of current. So were you guys able to get that one so far? And how to, determine if it's negative or positive on this one? Hello, hello. Are we clear with that one? Same flow of current, they will be added with each other. Okay, but if different flow of current, then they will be subtracted, okay, with each other. So are we clear with this one, guys? Okay, because later on we're going to have a negative sign right here on the next example. But for now, since they have the same law of current, okay, so this will be uh, addition. Okay, they will be added with each other. Anyway, so going back with our original assumption, so we have this counterclockwise and then clockwise. So those two will be added with each other. So they have the same flow of current. Okay, so that is why we have this negative 2 times I1 plus I2 right here. Okay, and then equal to 0. So after that, you can now uh, distribute this one, negative 2 times I1, negative 2 times I2. Then after that, you will have this equation right here, and then you can now add the same units. So we have 2 I1s. Okay, so negative 2 I1 minus 4 I1, so it will become negative 6 I1 and then negative 2 I2. So we could say that this is now your final equation, okay, when it comes to this loop I1, okay, or mesh I1 right here. Okay, so are we clear so far with this simplified form of equation of I1? Okay, very good, Mr. Maba. Very good, Mr. Donato. What about the others? So just let me know if you guys need more time to analyze, and then maybe, I can explain it one more time on how did we come up with this kind of equation. Okay, very good. So 4 or 5 people. So I hope the others can follow, okay? Pag may 3 mesh, magiging R1 plus I2 plus I3. Uh, no, no, no. If it's, so someone is asking, so I think this is Mr. Isagani. So, sir, pag may 3 mesh, magiging R times I1 plus I2 plus I3. No, because if we have 3 mesh, okay, the setup will be, so just for example, the setup will become like this already. Okay. So let's say this is a resistor now, and then this is a voltage source, positive, negative, negative, and then like this. So let's say this is now your loop number 3. Okay. So if it's 3 meshes, then in here we still have the same assumption. Okay, it will come up with this one, and in here it will just give you another assumption wherein we're only dealing with uh, I2, okay, and then I3, okay. So wherever they are going to, let's say, meet, okay, then those are the only things that you need to consider. So for example, right here, we have I3 flowing in right here, and then we have I2 flowing in right here. So as you guys can see, we have, let's say, you're having your loops or equation in I2, so it will become I2 times, oops, my bad, it will become R, let's just say that this is R3, R4, okay, this resistor right here. So it will become R4 times I2, okay. So this one is opposing this flow of current, so this will become negative I3. Okay, so it will never become 3 uh, currents in one equation. So it's always 2 currents in one equation. Okay, so yeah. But of course, in here, you have another one wherein you're going to deal with, let's say, R2 times, they have the same flow of current, so it's I1 plus I2. So that's basically what's happening with your middle uh, part right here. So you have to deal with this one and then deal with this one also. Okay. So instead of having two equation, it will just give you three equation. Then of course three unknowns at the same time. Okay, but in here two equations and then two unknowns only. All right. So going back with our ayun na, hanggang doon na lang ang kanyang limitation. Anyway, let me just delete that one. So you will get this one as your equation number one for the I1. So the same method or same process with the I2 right here. So let's start with here first. So we have I2, okay, or resistor 2, okay, times I1 plus I2 since they have the same flow of current. And then after that, will give you negative 7, okay, and then positive I1, I2 times 1, okay. And then after that, you can distribute this 2 right here, and then it will give you this one as your final equation. Okay, so again, I'll give you maybe 20 seconds to analyze the second equation. So again, just give me a thumbs up once you were able to get this one already. Or if not, then maybe we can do this one from the scratch again, like using the paint application. Okay, so Mr. Maaba already got this one. So you can start anywhere you want. So you can start right here, negative 7 plus I2 times 1 ohm, and then plus I2 times I2 plus I1. Okay, so as long as you have the correct polarity, then even though you shuffle this one, you'll still get the same equation. So this is your second equation. So after that, you can now have this one as your final, equation for equation number one, and then equation number two. Then you can rearrange them, okay? Wherein I1 and I1 is aligned with each other in one column only, and then I2 and I2 is aligned with each other, okay? Wherein they are in one column. So the same with the third value, okay, which is 28 and then 7. So again, your I1 will be your X, okay, if you're going to use the calculator. And then I2 will be the Y, okay, and the 28 and 7 will be the Z. So it's X, Y, and then Z. Then after that, you can use simultaneous equation, okay, or you can use the calculator already, okay. And then after that, you will get this one as your result. So X or I1 is 5, and then Y is, or I2 is negative 1. Okay, so I would like you guys to verify this one. Okay, so please use your calculator or you can use simultaneous equation. Okay, and then please check if we have the same value. All right, so anyone who's trying to solve this one, whether we have the same result or no. Okay, so who's trying to solve this one? Baka kasi mamaya wala naman pala, naghihintay tayo sa wala. Okay, so while waiting, maybe yes, Miss Ginoran, are you trying to solve this one? So let us use simultaneous equation. So in here, I would like to solve for the I2. Okay, so I'll multiply this 1 by 3, and then okay, you can also do this one. Instead of having a negative sign right here, you can just multiply this 1 by negative 3, so that you can just add them as 1. Okay. So before that, of course, we have to get the final result of this one. So 6 I sub 1 plus 2 I sub 2 is equal to 28. Okay, and then on this side, it will give you negative 6 I sub 1 plus, it's negative 6, 9 pala, 9 I sub 2, and it's equal to 7 parting 21, negative 21. Okay, and then you can now add them. So of course, this one will be cancelled. And then 2 I sub 2 minus negative 9 I sub 2, so it will give you negative 7 I sub 2 is equal to 28 minus 21 is 7. Okay, and then you can transpose this one on the other side. I2 is equal to 7 divided by negative 7 will give you 1 ampere. Okay, my bad, negative, since negative pala to. So it's negative 1 ampere for I sub 2. Okay. And then for the I sub 1, so the same concept. So what I will do is, okay, maybe meron pa yung kanina. Yeah. Is I will eliminate now the I sub 2 for us to be able to get the value of I1. So in here, I have to multiply this 1 by 3 and this 1 by 2. Okay, by 3. And then this one is by negative 2. Okay, then let's try to solve this one. So 3 times 6 is 18. I sub 1 plus 6 I sub 2 is equal to 2856 plus 2874. How about 1624? 816. How about? I think it's 84. Let me just check. 28 times 3 is, yeah, 84. Not 74. Okay, 84. And then right here we have negative 4. What was this again? 6 times 3 is 18. 18. Negative 4 I sub 1 plus, my bad, it's negative 6 I sub 2. Then equal to negative 14. Okay, then we can now add them. So 18 minus 4 is 14 I sub 1. And then we can now cancel this one. And this one is 84 minus 14 is equal to 70. Okay, so from here we can now transpose this 14 on the other side. So 70 divided by 14 will give as a result of 70 divided by 14, 5 ampere. Okay, so in here we now have negative 1 amp for the I2 and then 5 amps for the I1. Okay, so this will be a lot easier if you're going to use your calculator. Okay, in just less than a minute, you already have the value of I2 as negative 1 and then I1 as 5 ampere. Okay, so were you guys able to follow on how did we solve for the I1 and I2? Alright, so very good, Miss Maris, Mr. Tanato, Miss Ginoran. What about the others? So maybe kumakain na yung iba. Anyway, so yeah, that's it for the example number 1, okay? And then in here, they're using blah blah blah. So, oops, parang naulit. Kaya pala. And then in here, you can now write or redraw the circuit. So we have here 5 ampere. and then negative 1 ampere. So as you guys can see, we have a negative value, meaning our assumption of this flow of current right here is actually incorrect. So the correct one was actually clockwise. And then we now have a 1 ampere right here. Okay. But what about on the R2? What is the flow or the final flow of current on the R2? So if you guys are going to take a look on this one, okay, using the method of KCL just to check what is the current that is flowing on the R2 and then R3 right here. So of course for the I1 we have 5 ampere. Okay, so at this point we have 5 amps. So some will go right here and then some tama. Okay, so some will go right here and then some will go right here. Okay, or we already know that the current that is flowing right here is 1 amp. Okay, and then if we are going to analyze this one using KCL, so it will give you like let's just say that this is your I2. Okay, and this part right here is your I3. So and this one is your I1. So I1 minus, so it's leaving. Okay, so we have a my bad, negative 5 plus 1. But we have the same flow. Okay, entering is 5 and then entering is 1. And then right here we have, my bad, my assumption is incorrect. Okay, so this is not the uh, uh, 1 ampere right here, but the 1 ampere is right here. Okay, and then the 4 ampere, okay, will be flowing right here. Okay, so erase natin lahat. Okay. So baguhin natin lahat. Okay. So in here, the same concept with whatever we have from before. So as we all know, we have 5 ampere right here, and then some current will flow right here, and then some current will flow right here. Okay, so my bad on that one. Because what I did is I'm adding now the I2 and then the I1 at the same time. Okay. So in here, we have the I1 flowing in, and then we have here the, let's say, again, this is your I2. Okay, and then this is your I3. Okay,